So this is the second of the tutorial questions, where we have to work with discriminant functions, and we have to be able to differentiate between two cases. The cases being the contents of the covariance matrix. Okay, so it says consider a multivariate two-category classification problem in which two features are used. Each state of nature is equiprobable, which is useful to know, and we're given these probability distributions. So it's Gaussian, so the conditional probability here can be described as a normal distribution, where this is the mean. So this is mean 1 and mean 2, 3 and 1. And it's got a covariance matrix. And if for class 2, it's the same. It's mean 1 is -2, its mean 2 is -2, and it's got the same covariance as the first one. So for the first part, we assume that the covariance matrix is just equal to the identity matrix, and then they want us to find GI of x given these samples here. So that's where this formula comes in the green box here. For case 1 of two cases, the covariance matrix is equal to the variance times the identity matrix for all of the classes. So the identity matrix just looks like this. So it's a diagonal of 1s from the upper left to the bottom right. So the you know you have case 1 if your covariance matrix is of this form. You just have some kind of scalar value multiplied into it, and it's a diagonal like this. So in this case, we do have case 1 because you can consider the variance here to be equal to 1. In that case, it's going to be equal to the identity matrix as described in the problem. So the discriminant function for that looks like this. You plug in your variance here. X would be whatever sample you're looking at. So here we have our samples have two features, so this will be like a two-element vector. The mu is the mean, which is given to us, and the t just means it's transposed. So once we have that figured out, and my pen is acting weird. Okay. So once we have that sorted out, we can start working on this. Once you're able to identify all the quantities that you need, and once you know where to get them from, and you can figure out what case it is, then the problem ends up being relatively straightforward. So let's start. So let's try and find G1 of X1. Okay. So our objective is to find out what class the sample X1 belongs to. So to do that, remember, we're going to find G1 of X1, and we're going to find G2 of X2, and whichever one has the greater value will tell us if it belongs to class 1 or if it belongs to class 2. So if we start with just plugging in some values, this ends up being -1/2. And then for the first feature we get, so this is just X1. And from that we must subtract the means, mu1 and mu2. We've got to transpose that and multiply that with the same thing actually. Right? So again, where did I get this 3 and 1 from? That's from the means. Means that's given to us in the description of the probability density of these conditional probabilities. So then once you work out that math and you do the transpose, it'll look like this. and that works out to be negative 3.25. So we're going to keep that aside for now. Now we got to find g2 of x1. So we're working with the same sample set, but the discriminant function is different. And the difference there is seen in, oh, is that supposed to be negative? I think it's supposed to be negative. No, never mind. Yeah, so now the means are different. I meant to draw the arrow like this, but you know. So again, only the mean part of it changes because that's what the formula says. So g sub I of x uses mu sub I. So when we use the different discriminant functions for the same sample, the sample stays the same, but the mean that we use is different. And again, the mean is taken from the same place as before. So then if you work out this math, then it ends up being negative 9.25. So as it turns out, g1 of x1 is greater than g2 of x2. g1 again is like negative 3.25. So then we can say that the sample x1 will be classified as class 1.